Time and motion. Learning objectives. Units of measurement. Measurement of time. Units of time. Speed. Unit of speed. Motion. Study the following real-life situations taking place every day. You wake up in the morning and ask your mother, "What is the time?" After some time, the milkman knocks at your door. You go to him with a vessel and he asks you, "How much?" Your mother goes to a shopkeeper and asks him to give her a rope. The shopkeeper asks, "How long?" Your father goes to a fruit seller and asks him to give some bananas for you. The fruit seller asks, "How many, sir?" Now pay attention to words written in colored letters. What do they all signify? They all inquire about the quantity or number you or your parents want to have. Now think what would be your answer in the above examples. It may be 6 o'clock, 1 liter, 2 meter, 1 dozen, etc. Consider your statement now. When you say 1 liter, you wanted to express that you need a quantity or volume of milk which fills up a container of 1 liter volume. So, what you tell to the milkman is the measurement, which you did after comparing the required quantity against the fixed quantity of the same kind. Thus, measurement is the comparison of an unknown quantity with some fixed, or standard, quantity of the same kind. Units of measurement. The fixed quantity, referred to in the above paragraph, is called as the unit of measurement. Different kinds of standards or units have been devised by man through the ages. The units are chosen mostly on the basis of convenience or some logic. A measurement always consists of two factors. I, a number which describes the numerical value of the measure. 2, a unit, in which the quantity is measured. For example, Ram purchased 2 kilograms tomatoes. In this case, 2 is the number which describes the numerical value of the measure, while kilogram, kg, is the unit of that quantity. Need of standard units. In olden days, people used some general measures to measure quantities. For example, to measure length or distances, they used handspan, cubit, yard, etc. But, when it comes to accurate measurements, these units of measurements cannot be relied upon as they vary from person to person and place to place. Stretch your handspan fully and mark its extremities on a sheet of paper. Ask one of your friends to do the same on another sheet. Now compare the handspans of both of you, measuring each of them with a centimeter scale. Compare the sizes of both the handspans. Are they exactly the same? No, they differ from each other. It means you cannot rely upon handspan to measure length accurately. The earliest method of measuring time was also not accurate. Romans used a sand clock to measure time. Likewise, sundials were also used to mark the changing position of the sun with the passage of time. These units, too, had their own shortcomings. For example, you cannot tell time by a sundial if there are dark clouds in the sky, as it needs a certain amount of light to measure time. So, in order to have accuracy of measurement and also the uniformity of measures across the world, the General Conference of Weights and Measures was organized in 1960, which recommended the establishment of standard units. The new system of standard units was named originally as Système International Units, French. The primary standard units devised under this system are meter. It is the unit of length or distance. It is written as m. Kilogram. It is the unit of mass and is written as kg. Second. Second is the unit of time and it is written as sec. Kelvin. Kelvin is the standard unit of temperature. It is written as K. However, degree Celsius or degree centigrade, degree Celsius, is still the most commonly used unit of temperature in the present world. With these initial standard units, This system has specified many more standard units for various quantities. You will read about them in further classes. Conventions in writing SI units. A number of conventions, general rules, need to be followed while writing SI units. These include the following. 1. Standard units are always written in singular number. For example, 10 meters is correct, 10 milliseconds is incorrect. 2. The abbreviation of a standard unit does not have a period, full stop, of its own. It is followed by a period which appears in the end of a sentence. For example, he needs 10 meters cloth. Correct. He needs 10 meters cloth. Incorrect. 3. The unit is separated from the numeral with a space. For example, 10 meters, correct, 10 meters, incorrect. 4. When you have numerals, write unit symbols with them. For example, 100 centimeters, correct, 100 centimeter, incorrect. 5. Most standard units are expressed by small letter symbols. For example, m, meter, kg, kilogram, and s, second, etc. But when a unit symbol has been taken from the name of a scientist, it is written in capital letter. For example, J, joule, N, Newton, A, ampere, V, volt, etc. 6. When you express temperature in Kelvin, do not use degree symbol, degree. The degree symbol is used only in case of degree Celsius or degree centigrade. 7. Do not mix words and symbols in your writing. In numericals, write only symbols, not words. Sci facts. Facts. In 1791, the French Academy of Science devised a metric system of measurement based on decimal system. In 1901, a system of standard units, based on meter, kilogram and second, MKS, was suggested by C. Georgi. Multiples and submultiples of SI units. The standard units, SI, are used in most countries of the present-day world. A base unit in this system is taken as per the most commonly used fraction. For example, meter for distance, not centimeter or kilometer, kg for mass, not gram or quintal, etc. However, at many places, people need to measure the different amounts of quantities which require shorter or larger variants of standard units. This is facilitated by the multiples and submultiples of standard units. These multiples and submultiples are related to the base unit by the powers of 10. Each of these powers has a separate prefix and a symbol for correct representation with the symbol of standard unit. Multiples of standard units. Multiple. Prefix. Symbol. 10 into 9 or 000, 000, 000, 000. Giga. G. 10 into 6 or 1000, 000. Mega. M. 10 into 3 or 1000. Kilo. K. 10 into 2 or 100. Hecto. H. 10 into or 10. Deca. Da. Submultiples of standard units. Submultiple. Prefix. Symbol. 10 into -1 or 1 upon 10. Deci. D. 10 into -2 or 1 upon 100. Centi. C. 10 into -3 or 1 upon 1000. Milli. M. 10 into -6 or 1 upon 10 lakh. Micro. Mu. Mu. 10 into -9 or 1 upon 100 crore. Nano. N. Measurement of time. You have read in the foregoing paragraphs that people in olden days used primitive methods like sand clock, sundials, etc. to measure time. In a sand clock, a certain amount of sand falls into the lower chamber in a definite time. This helps people count the time in short intervals, but it cannot provide finer time measurements. You cannot count seconds and further smaller intervals of time with a sand clock. Sundials can measure time with enough fineness. The sundial in Jantar Mantar can measure time intervals as short as 2 seconds. Sundial. Sand clock. Jantar Mantar at Delhi. The discovery of pendulum's principle paved way for the invention of pendulum clock. The Italian scientist, Galileo, discovered the principle of pendulum. He told that a pendulum completes all the swings in equal time, irrespective of whether they are long or short. In 1658, Huygens used a pendulum clock to measure time. Later, mechanical clocks were also developed by people to measure time. In mechanical clocks, a balance wheel is used in place of a pendulum. Nowadays, clocks and watches are based on the oscillations made by the quartz crystal. Pendulum clock. Mechanical watch. Quartz watch. Units of time. The standard unit of time is second, s. Some bigger units of time are listed below. 1 minute equals 60 seconds. 1 hour equals 60 minutes. 1 day equals 24 hours. 1 year equals 365 and 1/4 days. A quarter of the day is left uncounted for first 3 years, and is counted as 1 full day after 4 years. Such a year is called a leap year. Measuring short time intervals. Many a time you need to measure a short interval of time. For example, the short interval of time is recorded when athletes run to win a race. There, even fractions of seconds are also counted to measure the time intervals accurately. This is done by using a stopwatch. A stopwatch is controlled by on-off switches which help you record the time interval as and when needed. Stopwatch. Activity 11.1. Take a stopwatch and go in the nearby park with your friend. Ask him to run for a short distance, say 100 meters. Switch on the stopwatch when your friend starts running and switch it off when he finishes his run. Repeat the activity, this time your friend measuring the time you take to run the same distance. Speed. The distance traveled by an object in a given unit of time is called its speed. We can find out the speed of a moving object with the following relation. Let the speed of the object be s, the distance traveled at n time interval t. Then it is written as follows. d upon t equals s. Unit of speed. The unit of speed can be derived from the above relation. Speed equals distance traveled upon time interval. The SI unit of speed is the meter per second, abbreviated as meter per second or ms, and 1. But the most common unit of speed in everyday usage is the kilometer per hour or kilometer per hour. In the US and UK, miles per hour or mile per hour. For air and marine, the knot is commonly used. Speed in different things. Different things move at different speeds. For example, a man can run, at the most, about 36 kilometers per hour, while a cheetah, which is believed to be the fastest running animal, can run at a speed of about 90 kilometers per hour. While a common motorcycle can run up to 100 kilometers per hour, a jet plane can fly up to 3,600 kilometers per hour. See the following examples that show how to calculate speed through the formula derived above. Example 1. An athlete runs 100 meters in 10s. Calculate his speed. Solution. Speed equals distance traveled upon time interval equals 100 upon 10 equals 10 ms. Example 2. A car travels a distance of 360 kilometers in 6 hours. Calculate its speed in kilometer per hour. Solution. Speed equals distance traveled upon time interval equals 360 upon 6 equals 60 km/h. Example 3. A train covers a distance of 180 kilometers in 2 hours. Calculate its speed in meter per second. Solution. Speed equals distance traveled. Time interval equals 180 upon 2 equals 90 kilometers per hour. To convert a speed from kilometer per hour into meter per second, it should be multiplied with 5 upon 18. Thus, 90 multiply 5 upon 18 equals 25 ms. Motion. In your everyday life, you see a number of objects moving from place to place using the different modes of locomotion or movement. For example, the fast-running car on the road, children going to school, birds flying in the sky, fish swimming underwater, fast-running car on the road, children walking, bird flying, fish swimming. In every example, you observe that each of the moving objects changes its position with respect to its surroundings with time. This phenomenon is called as motion. Thus, you can say that motion is the change in an object's position with respect to its surroundings with time. Motion can be slow or fast. When you walk, you have a slow motion, and when you run, you have a fast motion. Motion along a straight line. A motion occurring along a straight line can be of two types: uniform and non-uniform motions. Uniform motion. If an object covers equal spaces in equal intervals of time, its motion is called uniform motion. Distance, km, 0, 15 minutes, 15 minutes, 15 minutes, 15, 30, 45, 10, 20, 30, 40, 50, 60. Distance time graph for uniform motion. Take time along x-axis and distance along y-axis. Analyze the given data and make a proper choice of scale for time and distance. Plot the points. Join the all points. Consider any 2 points, A, B, on the straight line graph. Draw perpendiculars from A and B to x and y axes. Join A to C to get a right-angled triangle ACB. The distance time graph is a straight line showing that the motion is uniform. From the distance time graph, dt, we calculate the speed. Speed equals distance traveled, time interval, equals d upon t. The slope of the graph, up, equals bc upon ac. Speed equals 40 minus 30 upon 15, equals 10 upon 15, equals 0.66 km/mm. The ratio bc upon ac is the slope of the graph. Hence the slope of the distance time graph gives the speed of the moving object. Here, the car is covering a distance of 0.66 kilometers per minute interval. So, it is covering equal distances in equal intervals of time. Hence, it is under a uniform motion. Non-uniform motion. If an object covers unequal spaces in equal intervals of time, its motion is said to be non-uniform. For example, distance, km, 0 15 minutes, 15 minutes, 10 minutes, 15, 30, 45, 10, 20, 30, 40, 50, 60. Here, the car is taking unequal intervals of time to cover equal distances, so its motion is non-uniform. Keywords: measurement, comparison of an unknown quantity with a known standard quantity. SI units, units recognized by System International, SI, D unites. Sand clock, a tool that regulates the FL of sand against time intervals, also known as hourglass. Sundial, a dial made to count time intervals through the shadow's movement, as in Jantar Mantar. Unit, a standard fraction in which a quantity is measured. Summary. Measurement is the comparison of an unknown quantity with some known fixed, or standard, quantity of the same kind. People in olden days used to measure things through primitive methods, which yielded inaccurate and non-uniform measurements. Standard, SI, units are accurate and uniform in every part of the world. Meter, kilogram, second, Kelvin, etc. are some standard, SI, units. A number of conventions are followed while writing standard units. Units have multiples and submultiples. Sand clock, sundials, etc. were used to measure time in olden days. Time is measured by counting time intervals through oscillations. Different types of watches, pendulum, wheel balance, quartz, etc. are used to measure time nowadays. Motion is change in the position of an object with respect to its surroundings with time. Motion along a straight time can be uniform or non-uniform. Speed of an object can be calculated by dividing the distance traveled in intervals of time taken.